So this is section 5.2, and we repeat the log rule for integration. And again, that is that, you know, if I gotta watch my hand there.
Hi.
Quit.
Sorry, I don't understand.
Yeah, get rid of that. I don't like that stuff. Okay, so, try to keep my hand off of there. But so repeat log rule for integration. Again, if you have something like, a to b of 1 over x dx, and you know that a is less than, 0, is less than a is less than b, then this definite integral, 1 over x dx, would be just the logarithm of b minus the logarithm of a. Okay, that's just the antiderivative of 1 over x, where x is positive, because I know x is positive because of the a and b there. However, if I just have a general antiderivative and I don't know where x might be, then I need to toss in some absolute values. Similarly, if I was doing something like, let's put it up here, integral from a to b of 1 over x dx, where I know in this case that a is less than b, but they're both negative, then in that case, this integral a to b of 1 over x dx absolutely better be the absolute value. So natural log of the absolute value of b minus natural log of the absolute value of a. Because you have a perfectly valid function here that you're summing up over these numbers, and I can put negative numbers into 1 over x, so it will sum up. And so it better have some sort of answer. And if I didn't have those absolute values, then I couldn't take the logarithm of b or a because they're negative. So it is very important that you have that absolute value in there. And I don't think I had mentioned the plus c there. So there's our antiderivative. And now, we can use that with a chain rule sort of thing. So, suppose I want to, did it again. Try that again. At least whoever that voice is didn't come on. Okay, so suppose I want to do the antiderivative of x over x squared plus 1 dx. Then, in that case, I can do a substitution here. So I could let u equal x squared plus 1, and then du is equal to 2x dx. Now, I don't have a 2x dx up here, so what I'll have to do is I'll do a 1/2 2x over x squared plus 1 dx, which gives me my 2x dx, and so I'll have 1/2 and I simply have the antiderivative of 1 over u du. And so when I do this antiderivative, I get 1/2 the natural log of the absolute value of u plus c. And so that's 1/2 the natural log of x squared plus 1 under absolute value plus c. Now, in this particular case, because x squared plus 1 is always positive, I could actually now drop those absolute values. But it's not until I realize that the x squared plus 1 is always greater than 0 that this makes sense to drop those absolute values. Okay, so there's a case of using the chain rule. And then really the rest of this section is devoted to applying the logarithm to determine some derivatives, well, actually antiderivatives, sorry, antiderivatives of some of the trig functions. So we'll look at that next.